This Zoom session is being brought to you by the Fractal Cybernetics. All right, this one's about circles and graphs. We're given an equation, y equals f of x. We'll derive a graph consisting of all the points with coordinates x by f of x. For example, y equals x squared. Well, we'll make a table. Here's a 5 points. Obviously, there'll be infinitely many points on the line, but on the curve. But we'll do finite approximations because we're finite ourselves. X squared is 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. So we plot 0.2 by 4, 1 by 1, 0 by 0, negative 1 by 1, negative 2 by 4. That's only 5 points. I've seen people draw this and then draw something which is that sharp point at the corner like this. Well, that's not quite right. You could also plot the point a half by a quarter, negative half by a quarter, a third by a ninth, negative third by negative ninth. It actually kind of slows down and actually has a horizontal tangent right at the bottom before it's sloping up again. This shape is called a parabola. Let me ask you a question. Have any of you seen that shape before? The answer is yes, but you didn't notice. Does this look at all recognizable, this shape, this U shape?
Yes.
Where have you seen it?
Yes.
Where?
Fascinating.
Where have you seen it?
Pre-calculus.
In a fridge? Oh, bridge, right. Yes. If the weight of the pavement road it's carrying is much heavier than the cable, yes, then the cable does tend towards a parabolic shape. If it's hanging free, it's a slightly different U shape called a catenary. Never mind that. Let's see. It's also, if you look at the back of the mirror of a flashlight, that mirror has a parabolic cross section because it takes all the light coming from a focus, which is about here, and bounces off them to form parallel beams. It's also the orbits of comets, and also, back in the old, the before times when we were meeting in person, I would stop for a moment to throw an eraser across the room and say, you see, it took a parabolic arc. But never mind that. Anyhow, so that's the parabola. Here's an equation, 2x plus 3y equals 6. And okay, if x is 0, we can solve for y, it's 2. If y is 0, then solve for x is 3. So it goes through 0 by 2 and 3 by 0. And this particular form of equation always graphs as a line, so you get this straight line here. Okay. Now, if you're going to graph something, there may be symmetries. For example, this graph, if you flip it left for right, you get the same graph. So it's called, that says it's symmetrical around across the y-axis. If you flip it to the y-axis, that's this. There's also symmetries through the x-axis if x by y is on the graph and x by negative y is on the graph. There's also rotating around the origin. If x by y is on the graph, then negative x by negative y is on the graph. So these are various kinds of symmetries. For example, this is a graph which is symmetrical through the x-axis. This is a graph that's symmetrical through the y-axis. Flip it like that and it's the same. This is a graph that's symmetrical around the origin. And so, okay, to find a point symmetrical to negative 2 by 1, through the x-axis, you change the y value, negative 2 by negative 1. Through the y-axis, we flip the x value, so it's 2 by 1. Symmetrical around the origin, you flip both of these, 2 by negative 1. Similar thing happens with these. If you have a graph like this, and here and here where it meets the x-axis, those are called the x-intercepts. And you can solve it by solving the equation y equals 0. Here is where the graph intercepts the y-axis. That's the y-intercept. And you solve it by setting x equal to 0. So for example, this graph here has a y-intercept of y equals 2. Has an x-intercept at negative 4, negative 2, positive 2, and positive 4. Now, okay, this is a bit of jumping around this, that, the other. Now we're getting to circles. The question is, here we have a circle with radius r and center h by k. What's the equation for a point on the circle? X by y. given h by k center and radius r, what's the equation for x and y? Well, the distance between xy and hk is r. And okay, and we use the Pythagorean, the distance formula. The distance between this point and this point is the square root of the sum of the squares of the differences of the coordinates. X minus h squared plus y minus k squared, square root equals r. Now, okay, usually what we do is we get rid of the square root because it's an annoying sign, and just write it this way: x minus h all squared plus y minus k all squared equals r squared. This is the equation of a circle with center h by k and radius r. So for example, say the center is -2 by 7 and the radius is 5. What's the equation? Well, x minus -2 squared plus y minus 7 squared equals 5 squared. Generally, you kind of clean it up a bit. Minus a negative is plus, and 5 squared is 25. So the equation is x plus 2 all squared minus y plus y minus 7 all squared equals 25, and that's an equation. Okay, maybe you'll expand this out. X squared plus 2x plus 4 plus y squared minus 14y plus 49 equals 25, or even combine the constant values. That's doable. It's not necessary. So, examples. Write equations for the circle with center 4 by -3 and radius 5. Okay, x minus 4, that's squared, plus y minus -3, that's squared, equals 5 squared. Okay, y minus -3 is y plus 3, 5 squared equals 25. X minus 4 all squared plus y plus 3 all squared equals 25. That's called the standard form. It's easy to read off, or relatively easy off the center and radius. To get the radius, you have to take square root to get the 5 back. You have to read this y plus 3 as a y minus -3. But whatever. Okay, however, I mentioned we could expand this. This would be x minus 4 is x squared minus 8x plus 16. Y plus 3 all squared is y squared plus 6y plus 9. And all those add to 25. And if you subtract 25 from both sides, lo and behold, in this case, all the constants cancel out, and you get x squared minus 8x plus y squared plus 6y equals 0. And that's this one's version of the general form. Okay, here, the book asks, what center, radius, and intercepts are there for the circle with this equation? Twice x minus 3 squared plus twice y squared equals 8. Okay, first of all, these 2's are annoying, and they're in the way. So let's divide throughout by 2 and get x minus 3 squared plus y squared equals 4, which is 2 squared. Now, okay, this is x minus 3. This is y minus 0. This 4 is 2 squared. So the center is 3 by 0, and the radius is 2. Okay, that's center and radius. To find intercepts, well, to find the y-intercept, we set x equal to 0 in here. So you get 9 plus y squared equals 4. So y squared is -5, no real number. So there's no real y-intercept. For y equals 0, let's plug in y equals 0 here. Get x minus 3 squared equals 2 squared. Solve a bit, take square roots. X minus 3 equals plus and minus 2. Add 3 to both sides. X is 5 or 1. Those are the x-intercepts. Find an equation of the circle with a diameter ending at 1 by 4 and -3 by 2. So let's draw a crude diagram. Here's a circle. Here's 1 point, -3 by 2. Here's 1 by 4. Okay, well, first you'll need is a center, but that's easy. It's the midpoint of this interval. Okay, so -3 plus 1 over 2 is the x-coordinate. 2 plus 4 over 2 is the y-coordinate. It comes out to -1 by 3. Good. So we have the center. The radius will be, let's say, the distance between, let's say, this point, 1 by 4, and -1 by 3. So it'll be square root of 1 minus -1 square that, plus 4 minus 3 square that. That's 2 squared plus 1 squared. That's 4 plus 1. Root of that is √5. So remember, the equation is x minus h squared plus y minus k squared equals r squared. H is -1 here. K is 3 here. R is √5, but remember to square that. It's r squared. And so we get x plus 1 squared plus y minus 3 squared equals 5. And there's the standard version of the equation. Here they are asking you to do some fancy stuff. I'm going to cheat a little bit by doing a geometric construction. Here we have a circle with equation x squared plus y squared equals 9. I have a square inscribed inside that circle. What is its area? Okay, well, 9 is 3 squared, so this is really a circle with radius 3. And these are radii, 3, 3, 3, and 3. Now, okay, so here we do what's called a geometric dissection. Here you have this square with these diagonals, 3 plus 3, 3 plus 3. Let's break it into these 4 triangles, reassemble them, 3, 3, 3, 3, 3, 3, 3, 3. So these are 2 squares with side 3. That's the area is twice 3 squared. That's twice 9. It's 18. So this square here had area 18. Okay.